Hello Flight Simmers and welcome back to Alpha Hotel Flight Simulator Training. This video is part 1 of our training series on the most ubiquitous panel in the game, the Garmin G1000. This video will provide an overview of the system and its controls and then cover flight instrumentation and aircraft system displays. Part 2 will cover using the autopilot and Part 3 will cover using the GPS. The G1000 is installed in numerous aircraft and Flight Simulator. In the Standard Edition, it's installed in the Cessna 172 G1000 Edition, the DA40NG Diamond Star, the G36 Beechcraft Bonanza, the Diamond DA62 Twin Superstar, and the Cessna 208 Grand Caravan. In the Deluxe Edition, it's installed in the G58 Beechcraft Baron and is installed in the Cirrus SR22 from the Premium Deluxe Edition. There are also G950 panels that function pretty much identically to the G1000 panel in some of the Pilatus PC6 models that came with the Game of the Year upgrade. And the G1000 is also installed in numerous third-party aircraft available through the marketplace or online. In addition, the TBM 930 features a Garmin 3000 panel, and the Citation Longitude in the Premium Deluxe Edition features a Garmin 5000 panel. These panels incorporate a touchscreen interface and do have some differences, but retain many of the same functions and features as the G1000. Many other aircraft in the game incorporate either the Garmin G3X or the Garmin Era 796 into their panels. And while I'll be conducting a separate series of videos on all of these avionics, they again retain many of the functions and features of the G1000. So learning the basics of the G1000 will give you a good fundamental understanding you can apply to all these other units, and a good foundation for using any glass or EFIS-equipped aircraft, including the custom avionics packages found on many of the jet aircraft in the game. We'll be focusing our training in this video on the panel in the Cessna 172, but most of the G1000 panels are nearly identical. There will be some variation in the engine instrument displays depending on what type of aircraft you're flying. Other than that, the only real difference is where the autopilot controls are located. Some, like the 172, have them on both the primary flight display and the multifunction display, and both sets of controls work. Others, like the DA40NG, have them only on the multifunction display, while others, like the Cessna 208, have a separate flight control panel or autopilot control unit and have no autopilot controls located on the displays. I'll also mention that this tutorial is for the stock Garmin G1000 panel, not the G1000 NXI panel mod you can download from the marketplace. I will be conducting a separate video on the differences between the stock G1000 and the NXI in the not too distant future. So let's take a look at the G1000. So what exactly is the G1000? The Garmin G1000 is an integrated avionics suite that combines many functions and features into one system. These include an electronic flight instrument system, or EFIS, complete with synthetic vision, an IFR certified GPS receiver, dual VOR receivers, an ADF receiver, dual comm radios, aircraft systems and engine display and control, a 2-axis autopilot that's integrated with the heading and navigation system, and a Mode S transponder. The G1000 was one of the first avionics packages to bring a glass cockpit type system to general aviation when it was introduced in 2004, and it quickly became a popular option in new aircraft and is still one of the most popular advanced avionics suites in general aviation today. It made its first appearance in a Microsoft flight simulator in Flight Sim 10, though there were only 3 aircraft in the game that were equipped with it. It became one of the most common avionics packages in Flight Sim with the advent of Flight Sim 2020. Any aircraft in which the G1000 is installed is considered by the FAA to be a technically advanced aircraft, or TAA. A TAA is defined by the FAA as an aircraft that has an electronic primary flight display, an electronic multifunction display, and a 2-axis autopilot integrated with a heading guidance and navigation system. Currently, the FAA does not require an endorsement to fly a TAA as it does with high-performance, complex, or tailwheel aircraft. But in the real world, it's wise to get some training with a TAA if you're not familiar with its systems before you strike out on your own, particularly in instrument conditions. Like many avionics in the game, it's not difficult to find a manual for the G1000 online, but like many avionics in the game, there are many features that either work differently or just don't work in Flight Simulator, so the manual may be of limited use. Let's take a look at the system components of the G1000. Components that are visible to the pilot include two GDU 1040 display units and an audio control panel that's located between the two displays. The left display unit is configured as a primary flight display, or PFD, and the right display is configured as a multifunction display, or MFD. Internal system components include an air data computer, which receives air data information from the pedostatic system and the outside air temperature sensor to provide airspeed, altitude, and vertical speed data to the system. An attitude heading and reference system, or AHRS, which contains solid-state electronic tilt sensors and accelerometers that provide attitude and heading information to the system. These replace the mechanical gyroscopes that powered traditional heading and attitude instruments. The electronic components are more accurate, last longer, and are less prone to failure than the mechanical systems they replace. A magnetometer, which replaces a traditional magnetic compass and feeds magnetic heading information to the AHRS. An engine airframe unit, which receives data from the engine and airframe systems, such as engine temperatures and pressures, to display aircraft systems data. A Mode S transponder, which provides a little more data to ATC than a traditional Mode C transponder and can provide position data to other equipped aircraft. And an integrated avionics unit, which functions as a communications hub, receiving information from other components and routing them to the displays. They contain the GPS receiver, the common nav radios, and the central processor for the system. As mentioned earlier, controls are duplicated on both the PFD and MFD for most aircraft. These controls include navigation radio controls, autopilot controls, communication radio controls, a combined course select and altimeter set knob, a range select and cursor control knob, and controls for the GPS or FMS. Many of these controls function identically whether they're used on the PFD or the MFD. For example, I can control the COM radios or the nav radios using the control on either the MFD or the PFD. If both displays have autopilot controls, I can control the autopilot using either set of controls. They both work identically. But there are some controls that function differently depending on which display's control you're using. For example, with the range control knob, if I use the range control on the PFD, it controls the range on the inset map on the PFD down here. Whereas if I use the range control on the MFD, it controls the range on the big moving map on the MFD. And we'll talk about these differences as we go through the function of each control. At the bottom of the displays is a row of 12 buttons called Softkeys. I'm not sure if they're called Softkeys because they're made out of a soft rubber material in the real world or because their function is flexible. The display and function of these keys depends on which display they're located on and what keys have been selected or the menu level you're in. We'll cover these in depth later in the lesson. First, let's take a closer look at the PFD display areas. These include the navigation frequency box, the navigation status box, which displays information for the GPS. Most of this area will be blank or dashed if you don't have a point or flight plan loaded in the GPS. The automatic flight control system status box, which displays the status for the flight director and autopilot. And again, this area will be blank if you don't have the autopilot or flight director turned on. The COM frequency box, the EFIS display area, the inset map display area, the outside temperature display, which displays your current outside air temperature in degrees Celsius, the transponder and the transponder data box and system time display. This displays the current mode and code your transponder is currently in and the current local time in 24-hour format. In the stock G1000, this displays only local time and it can't be changed either to UTC or you can't adjust the clock, at least as far as I know. And then at the bottom you have the soft key function display area. All right, so let's take a look at the nav radio controls. Again, they're located up in the top left of the panel here, and the display is located on the top left of the PFD display. On the top left, we have a volume control knob, and when you manipulate this, it will show you the volume level that you have set as a percentage of the maximum volume, and this is now working now. So if you dial it down, it will get quieter, and if you dial it all the way to 0, you won't be able to hear the identifier at all. Once you stop manipulating that knob, that volume display will go away and it will go back to displaying the nav radio display again. So the nav radios are basically like any other digital radio that we've seen in the game. We have a standby frequency on the left-hand side and an active frequency on the right side for both radios. You have nav1 on the top and nav2 on the bottom. Whichever one has the white highlight with the black numbers is the one that you're controlling, and it also has the swap box there. And then I can change which radio I'm controlling using the button at the center of the nav knobs here. That will swap out which radio I am currently controlling. Just like the other radios in the game, the big knobs control the big digits, the little knobs control the little digits, and once I have dialed in what I want in the standby, I hit this little swap button, and that will swap it into the active. One neat feature about the G1000 and a lot of the other digital radios in the game is that it will display the identifier up here for me so that I don't have to dial in the Morse code to know that I am listening to the correct radio. Then I can control the CDI or the course of the VOR using the little triangular knob here. It says course there is the triangle. I manipulate that. It will change my VOR course, and you can see the head of the needle indicates the course I've selected, but it's also displayed numerically up at the top right of the HSI. Another little neat feature of the course control on the G1000 is that if I push the center of the triangular button, if I want to go directly to a VOR, it shows me, centers up the needle and shows me what that direct to course is going to be. So the VOR right now is behind us, it's up to the north. So that's kind of a handy little feature. Another feature that's kind of cool is if you dial in an ILS localizer frequency and swap that in there, it will give you the digital identifier there, but then it automatically will adjust the CDI course so that it is set to the front course of that localizer. I don't think the actual G1000 works like this. I think you have to actually load the approach into the FMS or GPS for this to work. But in Flight Sim, you just load in the frequency, and if it's receiving that transmitter, that localizer, will automatically set the CDI to that front course. And I can't manipulate the CDI now. It is fixed automatically to that front course there. Moving over to the right side of the display, we have the COM radio displays and the COM radio controls over here. They work pretty much the same as the VOR radios did. The volume control is to the right here and displays the volume level that you have set when you manipulate it. You have a swap key for swapping your active or your standby and your active frequency out. Whichever is highlighted is the one you're controlling. You can control which one you're controlling using the middle or pressing the center of the knob here, and that will switch which radio you're controlling. And then big knobs for big numbers and little knobs for little numbers. And one unique feature with this unit, you see it has a little lettering here that says emerge here. And what this does is if you press and hold this key, whichever is your active radio, it will automatically dial in the emergency frequency of 121.5. Not particularly helpful for flight simulators since there's nobody on that frequency, but it's modeled correctly, so that's kind of cool. And so that's how our COM radios work on the G1000. It's still probably easier to use your ATC window to control things if you're not using like a virtual ATC service or something like that. But that's a rundown of how the controls work. Now let's take a look at the flight instrumentation. The philosophy of an electronic flight instrument system, or EFIS, is to take a traditional instrument display and present it to the pilot in the most compact and efficient way possible. It also aims to provide the pilot with as much information as is necessary for safe flight without overloading the pilot with unnecessary information. You'll notice that the arrangement of the instruments on an EFIS display closely resembles the modern layout or six-pack you see with traditional or steam gauge instruments, with attitude information in the top center, airspeed on the top left, altitude and vertical speed on the top right, and heading and navigation information at the bottom center. This layout is a little more compact than a traditional instrument layout, with the vertical speed presented next to the altimeter and the functions of a turn coordinator rolled into other instruments. The instruments themselves have also been redesigned to give a pilot all the information they need to safely fly the aircraft in a precise and easy to see format. Let's look at the individual instrument components. The attitude display takes up pretty much the entire screen on the G1000's primary flight display, and this is fairly typical with an EFIS display. A horizon line is present across the entire screen, with brown below indicating ground and blue above indicating sky. The larger size of this display makes for more precise pitch and roll indication and control. Attitude reference marks are located at the top center of the display. There's a yellow pitch and roll indicator representing the aircraft's nose in the center of the display, with two yellow marks on each side representing the aircraft's wings. Pitch marks are displayed roughly 10 degrees above to 5 degrees below the aircraft's current attitude, with the smaller tick marks indicating 2.5 degree pitch increments and the larger ones indicating 5 degree increments. Red chevrons display between the 50 and 80 degrees nose up pitch marks and between the 30 and 80 degree nose down pitch marks. The marks point to the shortest direction to pitch for the horizon and are used to help pilots recover from unusual attitudes. The white triangle that points upward is the roll pointer and indicates the aircraft's current angle of bank. The downward facing triangle indicates 0 degrees of bank, and bank indications are made at 10, 20, 30, 45, and 60 degrees of bank. The bar under the roll pointer functions as an inclinometer or slip skid indicator and deflects in the direction that rudder input is needed, functioning the same as the inclinometer ball on a traditional turn coordinator. The magenta bars that overlay the pitch and roll indicators are the aircraft's flight director. These display pitch and roll commands that are used to fly the desired flight path entered through the automatic flight control system. We'll go into more detail on how to use this in the autopilot lesson, and I'll actually be putting together a quick look video on how to use a flight director. All G1000 aircraft and Microsoft Flight Simulator are also equipped with synthetic vision. When enabled, this provides a visual display of terrain, water, and airports on the primary flight display. This function is on by default and can be disabled using the Softkeys. So again, this is on by default, the synthetic vision here, and to turn it off, what I want to do is go down to the Softkeys and press the one that says PFD, and then press the one that says synthetic vision, and it is highlighted right now to tell me that it's on, not that I can't see that on the display, and then I just press that key and that will turn it off. And so now it is unhighlighted, telling me that it's off. If I want to turn it back on again, then I just press synthetic terrain and it turns on, highlights it again, and brings the synthetic vision back up. And then if I want to get back to the top level of the menu, I just press back until I don't see back anymore, and I am back at the top level of the menu. Now let's take a look at the airspeed indicator. It's located on the upper left side of the EFIS display. A range scale, or tape, is on the left side of the instrument and moves as airspeed increases or decreases. White marks on this scale indicate airspeed increments of 10 knots, and the black marks indicate airspeed increments of 5 knots. A pointer at the center of the scale points to the current indicated airspeed, and a box to the left of the pointer indicates the aircraft's current airspeed numerically. The range scaler tape features the same color markings found on traditional airspeed indicators for general aviation aircraft. So you have a white arc for your flap operating range, a green arc for your normal operating range, and the yellow arc for your caution range. Speeds above V and E are indicated with an alternating red and white cross hatching, and speeds below VSO are indicated in red. True airspeed is automatically calculated by the air data computer and is displayed at the bottom of the airspeed tape. The airspeed indicator also has a trend vector on the right side of the tape. This magenta line displays what the airspeed will be 7 seconds in the future if power, attitude, and configuration remain unchanged. You can display up to 4 reference speed bugs on your airspeed tape as well. In order to set those bugs up, you want to use the soft key that says timer reference from the main soft key menu. Hit that, and that will bring up this little box here. Then I will hit the middle of the cursor control knob here at the bottom right of the PFD, and that will activate the cursor. I'll use the big knob to roll down to the field that I want to turn on or off. I want to activate my rotation speed, and you'll notice these speeds are pre-populated. We have best glide speed in there, VR, VX, and VY, and those are from speeds that are set by the manufacturer. And I want to turn on my VR speed so I can see that when I'm taking off. All I got to do is highlight the on-off field there and then rotate it to the right. We'll turn it on. If I want to turn it back off, I'll just rotate the small knob to the left and that will turn it back off. And now this speed will display up on the airspeed tape when it's in range during my takeoff. I can also change these speeds. One thing I like to do is since I know when I'm going to have an engine failure in Flight Simulator, it's not an unknown, I will actually change this speed to my approach speed to display on an approach. And so I'll just highlight the field and then roll the small cursor knob left to right to change the speed. I'll roll it down to 65 knots, which is my approach speed in the 172. And you'll notice whenever I change it from the default, it will put a little asterisk up there just to give you kind of a note that says, hey, this is not the manufacturer's default speed you have in there, you have changed it. And then if I turn it on over here, it will just display up on the tape when it's in the speed tape range, and it won't do anything special. Even with that asterisk, it'll still show a normal G on that bug when we're coming on. All these show up. The G shows up, or the glide speed shows up as a G, VR shows up as an R, VX shows up as an X, VY shows up as a Y. And my personal preference on how I use these bugs is for takeoff, I like to have VR, VX, and VY on. So I have a reference for those for takeoff. Once I'm airborne and climbing out, I go ahead and turn those back off. And then I will set up best glide to approach speed again for approach and turn that on so I have a reference bug for my approach speed. So that's just personal preference on how I use those bugs. If you use the flight level change mode or FLC mode on the autopilot or flight director, a cyan speed bug will appear to the right side of the airspeed tape when in this mode, and that value will be displayed numerically in a box above the airspeed indicator. Both the bug and the box will not be displayed if this mode is not active. We'll talk more about this mode in our autopilot tutorial video. Now let's take a look at the altimeter. It's located on the upper right of the EFIS display. The altimeter is also displayed on a moving range display or tape with a pointer indicating the current altitude, which is also displayed numerically in a box to the right of the instrument. The large markings on the tape indicate altitude in 100-foot increments, and the smaller marks indicate 20-foot increments. There's also a magenta trend vector located on the left side of the tape. Like the trend vector on the airspeed indicator, this line indicates what the altitude will be 7 seconds in the future if power, attitude, and configuration remain unchanged. The current altimeter setting displays at the bottom of the altitude tape, and you can adjust this using the Baro set knob, which is the big knob underneath the triangular CDI course select knob. And so that is how that works. And you also have a altimeter reference bug that you can set that displays as a cyan marker on the left side of the altimeter tape, and then it also displays numerically what you have it set to at the top, the box of the top of the altimeter tape. This bug can be used for pilot reference to hold your altitude, your selected altitude, and it is also used for the autopilot altitude capture function, and it also serves as an altitude alerter. You set this bug using the Alt knob, which is at the bottom left of each display if both displays are equipped with autopilot controls. The big knob controls the setting of the bug in 1,000-foot increments, and the little knob controls the setting in 100-foot increments. The box will display the selected value in cyan with a black background when the aircraft is more than 1,000 feet from the selected altitude. When the aircraft is within 1,000 feet of the selected altitude, the box becomes cyan and with a value displayed in black. When the aircraft approaches 200 feet from the selected altitude, the value will turn back to cyan and flash approximately 10 times. If you deviate from the selected altitude by more than 200 feet, a single oral warning tone will sound and the value will display in amber. It will remain in amber until the condition is corrected or another altitude is selected. This alert will be disabled when the autopilot or flight director is tracking a glide slope. You can also display an altitude minimum bug on the altimeter tape. You typically use this for marking instrument approach minimums if you're shooting instrument approaches. The way you want to set this is press the timer ref soft key, and again press the middle button there to get the field active, and then roll it down to where it says minimums. Go to the on-off field and roll it to the right to turn it on. That will select baro, and that's the only setting we have on the 172 because we do not have a radar altimeter. Then we can rotate it over here to the field, the digit field, and it will set in 10-foot increments, and you can roll it up whatever altitude you'd like to set it at. And you can see it displays as a little blue cyan kind of V-looking symbol on the left-hand side of the altimeter tape. And it will also display the numerical value that you've selected once you turn the reference box off to the bottom or to the right and below the CDI course selection next to the HSI. The vertical speed indicator is located on the right side of the EFIS display, to the right of the altimeter. Like the other instruments we've talked about, the instrument has a range scale, pointer, and numerical value box. The large marks on the scale depict vertical speeds of 1,000 feet per minute, and the small marks are in 500 foot per minute increments. Unlike the airspeed and altimeter, the range scale on this instrument is static and the pointer moves. The pointer moves and indicates the current vertical speed, and the vertical speed displays numerically in the box attached to the pointer. When using the autopilot or flight director in vertical speed mode, a cyan bug will appear on the left side of the VSI at the selected vertical speed, and it will appear in a cyan box above the VSI while this mode is active. When this mode is not active, the bug will not appear and the box will indicate dashes. Again, we'll go into more depth about this mode in our G1000 autopilot video. At the bottom of the PFD is the horizontal situation indicator, or HSI. This instrument combines the functions of a traditional heading indicator and navigation radio display. If you're not familiar with how to use an HSI, make sure to check out the quick look video on using an HSI on this channel. The white downward facing arrow is called the lubber line, and it indicates the aircraft's current magnetic heading on the compass rose, and then the magnetic heading is displayed numerically in a box just above the compass road. There's also a little magenta diamond here. This represents your aircraft's ground track. If you have a zero wind condition, no crosswind, then it will be kind of hidden behind the lubber line, but if you have a significant a significant crosswind, it'll go off to the side there, and you can see the difference between your aircraft's heading and your aircraft's ground track. The HSI can be set to display in a traditional 360-degree compass rose mode or a 140-degree arc mode, so we'll take a look at how to change between those two modes. So to change the display mode of the HSI, what you want to do is go to the PFD soft key and press that, and then go to the HSI format key in the middle of the display there and press that, and it'll give you the two options. The 360 HSI is what's currently selected, that is the rose mode, and then if I press arc HSI, it will highlight that and it will display in the arc mode. In rose mode, you have white tick marks that are reference points. These are stationary and don't move. They're located at the 90-degree points or on each wingtip, and then they're 45 degrees to the left and right of the nose and tail. That's for helping for things like procedure turns and holding patterns. And then we also have a trend rate indicator on the HSI. It's a magenta trend rate indicator, just like we had on the Airspeed and Altimeter. And that also functions as a turn rate indicator. These little white tick marks up here, that's what those are for. If you hit the outer tick mark here, you know that you're doing a standard rate turn or a 360-degree 2-minute turn. And if you hit the inner mark, then you know that you're doing a half standard rate turn. And then if your turn rate exceeds what you can show on the indicator, it'll put a little arrow out there to show you that you're turning faster than what it can indicate on the turn rate indicator. There's also a cyan heading bug that's on the HSI. This can be used for the heading select mode on the autopilot, but it can also be used for pilot reference. So let's take a look at how that works. You can set this bug using the heading knob on the left side of the PFD and the MFD. If the MFD has autopilot controls, just rolling it left and right will move the heading bug, and you'll notice that the heading bug displays in a little magenta marker on the outside of the HSI, and then it gives you a numerical display of what heading you have that bug set to at the top left of the HSI. The other thing you can do with this heading knob is that if you press the center of the knob, it will center up the bug on the aircraft's current magnetic heading. There's a course deviation indicator, or CDI, in the center of the instrument in rose mode, and it's located at the bottom of the instrument in arc mode. This displays navigation course information. In rose mode, the to from indicator is located on the shaft of the needle. It's a to indication when it's pointed towards the arrow's head, and a from indication when it's pointed towards the tail. And the CDI scale is located in the center of the instrument. When you're in arc mode, the CDI doubles as a to from indicator. It will point up when to indication and down when it's a from indication, and the scale is located at the bottom of the instrument. The head of the CDI points to your selected course on the compass rose, and then the course is indicated numerically in magenta to the right of the compass rose. I think this is supposed to be green when you're in VOR mode, but that is not currently working correctly in Flight Simulator. The HSI can be set to display course information from Nav Radio 1, Nav Radio 2, or the GPS. Whenever you have it set to Nav Radio number 1, you will get a solid green CDI and will indicate VR1 to the top on the top left of the compass rose here. And if you have it set to Nav Radio number 2, it will be a hollow CDI or a two-line CDI, and it will indicate VOR number 2 on the top left of the compass rose there. And if you have either of those radios set up to receive a localizer, then it will display Loc 1 or Loc 2 as appropriate. If you have it set to the GPS, then you're going to get a magenta CDI, and it will say GPS and magenta to the top left here. It has a phase of flight annunciator over here that should tell you en route, terminal, or approach sensitivity, which determines where full scale deflection of the needle is. But in the stock unit, at least, of the G1000 in Flight Simulator, this is always stuck in en route, which means that full scale deflection of the CDI occurs at 2 miles. When you go beyond full scale deflection, it will actually tell you numerically how far you are off course. But if it is less than full scale deflection, that means you are less than 2 miles off course. Anytime that you are not receiving a signal from the navigation source you've selected, or if you don't have any data loaded into the GPS, the center or the deviation portion of the CDI will disappear. So let's take a look at how we change between these navigation sources on the HSI. So to select the course for the CDI, all you want to do is use the CDI soft key in the middle of the CDI keys here. You'll see this menu option if you're at the top level of the soft key menu. If you see anything other than this, then you should have a back over here somewhere, and just hit the back key until you get to this menu. You hit this. Currently, we are in the GPS source. I've got it going direct to Pine Bluff Airport, and we've got a magenta indicator, and it's got GPS over here to tell us that that's the source that we're in. If I hit the CDI key one time, it takes me over to Nav Radio number 1. I've got the localizer for Pine Bluff dialed in there, so it shows me Loc 1 over here, and then I got that solid green indicator on the CDI. And again, it loads the course in there for me automatically. You'll notice if I use the triangular course select knob, it doesn't do anything for me right now. If I hit CDI one more time, it'll bring me over to the VOR number 2 or nav radio number 2. Tells me VOR number 2 because I have Pine Bluff VOR dialed in there right now, and it gives me that hollow green indicator. And then you'll notice that if I move that triangle course knob now, I can actually set the course. The course changes, the arrow moves, and if I push in the middle, it will center up directly to the Pine Bluff VOR. If I hit CDI one more time, I'm back into the GPS source. You can also display two bearing pointers on the HSI. Whenever you've selected a bearing pointer to display, a white circle is going to appear on the inside of the compass rose on the HSI, at least in rose mode. And both bearing pointers are cyan. Bearing pointer number 1 is a thin, solid bearing pointer, where bearing pointer number 2 is a hollow or two-line bearing pointer. The bearing pointers can be set to display information from nav 1, nav 2, the GPS, or the ADF. When a bearing pointer has been set to display on the HSI, you'll also get a data block associated with that bearing pointer. For bearing pointer number 1, it will be on the lower left-hand side of the HSI rows, and for bearing pointer number 2, it will be on the lower right side. The information that will be displayed in this data block, on the top line, you'll have distance information. This will be DME if you're listening to a station that has DME, like a VOR DME or a localizer with DME. Obviously, if you're listening to a station that doesn't have DME, like an ADF or an NDB, you won't get any information in this field. And if you're listening, or if you have the source set to a GPS, then it will give you the distance to the next waypoint. The next line down will give you the digital ident, 3-letter identifier of the station, if it's a VOR or localizer or something like that, that you can get a digital ID from. And again, with an NDB, then you won't get the digital ID, you'll just see the frequency. With the GPS, it will show you the name of the next waypoint, the one that you're currently navigating to. And the last line just shows you what source you currently have that bearing pointer selected to. So on this particular picture here, we have nav2 selected to display on bearing pointer 1 and the ADF selected to display on bearing pointer number 2. If you have it selected to a source that's currently not receiving a station, or you have it selected to the GPS and there's not anything currently loaded in the GPS, it will just say no data, and then the bearing pointer will not display, but you will still get that white circle on the inside of the compass rose. So to select what I want to display on the bearing pointers, I go to the PFD menu option from the top level menu, and that will bring up this menu here. And to the left and right of center, we have bearing 1 and bearing 2. When I hit that key, it will cycle through the choices for displaying on that particular bearing pointer. So I hit bearing pointer 1 one time, and it brings up nav radio number 1. Currently I have the localizer dialed in for Pine Bluff, so it pops up that arrow, pops up the white circle, and shows me where the localizer is located. It does not have DME, so I don't get any distance information. It tells me I'm on nav 1. Hit it a second time, it'll bring up nav 2. That is Pine Bluff VOR, so it gives me the ident on that. It does have DME, so it gives me the distance to the station there, and now it's pointing at Pine Bluff VOR. Hit it one more time, that's going to bring up the GPS. Currently I have loaded directly to Pine Bluff Airport. So it tells me GPS, tells me that the waypoint I'm currently going to is Pine Bluff Airport, and then it tells me the GPS distance to that waypoint, and points to that waypoint with the bearing pointer. And if I hit it one more time, that brings up the ADF receiver, and so it just tells me that I'm on ADF. It tells me that the frequency I've got dialed in is 338. That's an NDB over near Stuttgart, Arkansas. And it points over towards that, and there's no DME on the ADF, so we can't get any DME information from that. Hit it one more time, and that will make the bearing pointers and the circle go away, and then I can cycle through all those different sources on bearing pointer 2, and you'll notice it brings up that hollow two-lined bearing pointer when I bring that bearing pointer up. If you're not familiar with how to use a bearing pointer, make sure to check out the video on navigating with ADFs and NDBs and bearing pointers on this channel. We talk primarily about using ADFs and NDBs in that video, but all of those techniques can be applied to using a bearing pointer with a VOR or any other source for that matter. When a glide slope is being received on a nav radio or calculated by the GPS, a glide slope indicator will be displayed to the left of the altimeter tape. This will consist of a G, a glide slope deviation scale, and a glide slope deviation indicator. The G and the deviation indicator will be displayed in green if the glide slope is being received on a nav radio, and magenta if the glide slope is being calculated by the GPS. In addition, marker beacon annunciations will be displayed above the glide slope display. These will display anytime the system is receiving a signal from a beacon, will display the appropriate letter and color for the type of beacon being received, and will display in the same position regardless of whether you're receiving and indicating a glide slope or not. So let's dive a little deeper into the soft keys at the bottom of the PFD. We've already covered the functions of several of the soft keys as we discussed the flight instruments, but let's talk about the basics of how the system operates and cover the functions in there that we haven't looked at yet. When you first power up the system or boot into a flight, the soft keys will be in what we call the top level menu, and this is what that looks like right here. You can tell that you are in the top level menu by the absence of a back key over where the nearest key is right now. Anytime you press on a key that doesn't instantly toggle something to happen, it will take you into a lower menu level. For example, if I press on the PFD key, that takes me into the PFD menu. And then if I press on the wind key, that takes me down a further level into the wind display menu. And you'll notice when I go into those lower level menus, a back key appears over in the second from the right soft key here, and pressing the back key will take you up a menu level. So this takes me back to the PFD menu, and then if I press back again, I'm back to the top level menu. So we can toggle a little inset map to appear over in the left-hand side of the PFD if we want to. To do that, we use the inset soft key from the top level of the soft key menu. If I hit that, it brings up the inset map, and then I have a couple options here. Topo should turn the topography or the terrain on and off, and Nextrad should turn the weather images on and off. I don't think that really works in Flight Simulator, and then if I hit the off key, that will turn the inset map off. The other thing you'll notice is that there is a range display right down here in the bottom right hand corner. That indicates the size of the map in miles, and that is from the aircraft to the edge of the map. So it's 5 miles from the aircraft to the edge of the map, and I can control that using the range display knob over on the right hand side of the PFD. If I roll it to the right, it brings the range out. So now we're looking at a 10-mile range, 15-mile range, 20-mile range, and so on. And so that's how we control that little inset map. And to again turn it off, press the off key, soft key, and that takes it away and brings you back to the top level of the soft key menu. So let's take a look at our other options that we haven't talked about yet in the PFD menu. We've already talked about the synthetic vision and how that turns your synthetic vision on and off. Let's go and look at the wind display menu. We have the option to put a wind display that will display the winds at your current altitude. You got 3 different options. Option 1 just gives you headwind and crosswind component. I've got it set up for a south wind of about 10 knots right now, so it's showing me my current direction that I'm facing. I've got a 10 knot crosswind and a 1 knot headwind component, and it would revert that around to show a tailwind if you had a tailwind as well. Option 2 just gives you an arrow to show you which direction the wind is coming from and then the speed. So it's pointing this direction, so that's coming from the south at about 10 knots. And then option 3 is basically the same, but it gives you the wind direction numerically as well. So right now it says that the wind is 180 at 10 knots, and it shows you where that's coming from. So option 3 is the most detailed. And then to turn that off, just hit the off key and then go back to get back to the PFD menu. You have an option also for displaying DME. If you click that, it will toggle your DME display on, which displays to the lower left of the HSI. It tells you're in DME display. It tells you it defaults to nav1. There is a way to change that, and we'll talk about that here in just a little bit. It tells me that nav1 is set to 16 nothing, and right now I'm 4.0 nautical miles DME away from this station. Personally, I prefer to put the bearing pointer up there instead because it also gives me DME information. It's faster to cycle between sources if I'm using that bearing selector. So that's my personal preference. I don't use the DME much, but it is there and available if you want to use it. We already talked about how to cycle through our bearing sources, and we talked about how to change the format on the HSI between the arc and the rows. And that is all the options available to you in the PFD menu. To get back to the main menu, just press back. The back key is gone, so we're at the top level of the menu again. The OBS key toggles what's called OBS mode on the GPS, and we'll talk more about this when we get into the lesson on the Garmin G1000 GPS. But basically, when you click this key, it turns this highlighted, and you're now in OBS mode, and it allows you to use whatever waypoint you're navigating to, like a VOR. You can change the course, you can intercept a radial to that that station where that waypoint wherever you're going. If you want to change course slightly from what you have in your GPS flight plan, you can do that. Click out of it, just click so that that's not highlighted anymore, and you will be back on your direct course to that waypoint, whatever you've got loaded in there. So the ADF DME menu brings up the menu where you control, where you can tune your ADF and where you can select your DME source for that DME display that we looked at in the PFD menu. You use, whenever you've got the whole field highlighted like this, you use the big knob to transfer between those two fields. So we're down in the DME mode right now. We can use the small knob to transfer sources. And so whatever source I have selected here is what's going to be displayed in that DME display that we had from the PFD menu. And then to tune the ADF, I go back up with the big knob, and then I use the little knob, and that makes it so I transfer or change these first two digits here. Again, like most ADFs, you can go anywhere between 0 to up to 17. So we'll dial it down to 3 here, and then to change which digit I'm using, use the big knob again, and that will allow you to change that digit, and then I can roll over one more and change the last digit. And then when I have what I want in there, I press enter, and that gets it back to the whole field being highlighted again. It says enter to transfer, and that will transfer into the active. This is our standby, this is our active. Hit enter, and now I've got that frequency dialed into the ADF. And so, and I'll need to put up the bearing pointer from the PFD menu to be able to display to be able to navigate from that. To get this menu to go away, just hit the ADF DME key again, and you are out of that menu. So the transponder soft key brings us into the transponder menu, which is where we can set the mode and code for our transponder. Over on the left, we have our modes. So we have standby, on, and alt. Whichever one's highlighted there is the mode you're in, either standby, on, or altitude reporting. Then if I want to enter a code, I hit the code soft key, and that brings up digits that I can enter. So I just enter the code that I want. Say if I was told to squawk a code of 2345, that enters a code of 2345 for me there, and then get back to the main transponder menu, I hit back. If I'm told to squawk a VFR code, 1200, all I have to do is hit the VFR soft key, and that will automatically enter 1200 in there. And then if ATC asks me to ident, I just hit the ident key, and that will ident for ATC. And to get back to the main top level menu, just hit back again, and we're back at the top level menu. And most of the features in the timer reference menu we've already talked about. We talked about how to set our speeds and set our minimum bugs, altitude minimum bugs. The other feature that's in this menu here is a timer. Right now all it does, it counts up, and so to do that you want to hit the middle of the cursor button, and that'll put a field on the timer there. Then roll it over to start and hit enter, and that will make it start counting up in seconds, and eventually it does minutes and then hours. And then when you reach the time that you want, or you want to restart your clock, hit enter again. That will stop the timer, and then to reset it back to 0, hit enter again, and that will bring it back to 0 again. It used to have the feature where you could enter a time and count down, but if you do that without entering a time, it will just start counting up. And then if you try to actually enter a time, it will do that and freak out on you. If you want to reset that, just hit timer reference and bring it back up, and it will bring it back up. But unfortunately, the timer function to count down from a certain time is no longer working in Flight Sim, at least as of Sim Update 9. When it does work, if it does start to work again, there's no tone or anything that associated with it. It doesn't give you an oral alert or let you know in any way that that time has elapsed. It just starts counting up from 0 once you reach the time that you've set in there. So the nearest soft key brings up a list of the airports that are closest to you. You can scroll through these airports and their frequencies by using the big key. If you find an airport that you find interesting, you can hit enter to get more information about it. It gives the airport information, name, and the field elevation, all that sort of stuff, and then hit enter to get back to the menu. You can also hit direct and enter that in as a direct waypoint for your GPS if you want to do that. We'll talk more about this in the GPS lesson, but for now it's just know that that nearest key is a good way to bring up quick way to bring up airports that are close by if you want to look for airports that are close by. There's no way to display anything other than airports using this key on the PFD. The system provides alerts when an abnormal aircraft or flight instrument system condition is detected. Alerts are displayed to the right of the baro altimeter set window. And in the real aircraft, you should be able to pull up a list of your alerts using the alert soft key, and it should list them right there, but that function does not seem to be working in the stock version of the G1000 in Flight Simulator. There are 3 different levels of alerts. The highest level is warning. These are serious system component failures that could result in an emergency condition and require immediate corrective action. These alerts are displayed in red and generate a repeating tone from the system. An example of this would be an alternator failure, so I'll generate one of those by turning off the alternator. You can see I get a red low voltage alert over here, I get a warning down here, and then it flashes at me and it keeps doing the chime, and it will not stop doing that chime until I press the alert soft key. That will silence it, although if that condition were to correct itself and then come back, it's going to set the chime off again. I'll have to silence it a second time. The next level alert is the caution alert. These are system or component failures that could result in abnormal operations or could lead to an emergency condition and may require timely corrective action. These alerts are displayed in amber and generate a single alert tone from the system that doesn't need to be silenced. It just goes off once. An example of this would be if I were to run myself out of fuel in the left tank. I'll drain my left tank down here. You notice it'll pop up a low fuel left alert here, and then it will generate a caution down here. It only sounds the chime once. It's a little lower chime than I had for the warning chime, but this will continue to flash at me until I hit that alert soft key to acknowledge it. The final level of alert is the advisory alert. Normally these are normal system operations that are not necessarily always in use. I don't believe there's any on the 172 that would generate an advisory alert. Normally they're systems like anti-icing systems that you don't always use, but sometimes you use and you want to know when they're in use. So like on aircraft like the TBM 930 or the Beechcraft King Air, you would get these types of alerts. These alerts are displayed in white, and they do not generate a tone from the system when they activate, and I don't think they even flash an alert at you on the bottom right hand side of the screen, so there's no need to push the alert soft key for them. We do have duplicate controls for the GPS on both the bottom right of the PFD and the bottom right of the MFD. These do work slightly differently, and I'll cover most of that in the lesson on the GPS, but I did want to draw one key to your attention, and that's the menu key here. That brings up PFD options. The only option you have on the PFD is to set your PFD and MFD brightness levels. You can set these independently. To do that, press the cursor button when you're in this menu and then roll to the left to get it into manual. Otherwise, it will automatically adjust the brightness. And then you can go into the brightness field and you can scroll down. 100 is as bright as it gets, and then the lower you lower it, the dimmer the display will get. It's honestly easier to use the avionics knobs to brighten and dim these displays, but that will do both of the displays at the same time. So if you do want individual control of each display and put them on different brightnesses, then you can go into this menu and do that. The other trick about this menu is it's hard to get it to disappear. It says press the cursor knob to return to the base page. That will return you to this base page, but it won't make it disappear. The easiest way to make it go away is hit timer reference and then hit timer reference again, and then it is gone. In between the two displays, you have the audio control panel. It's pretty straightforward to use. At the top, you have controls for your comm radio. On the left side, you have the transmit selection switches, and on the right side, you have switches to select what you listen to. Right now, or each radio has a white arrow above it to indicate what you're currently using. So right now we're using COM1 to transmit, and we're listening to COM2. The only other radio I can select to transmit on is COM2, and you'll notice when I select that, it also selects to listen to COM2, and those are the only two that work. We don't have a COM3, and we can't, in Flight Sim, select to transmit on COM1 and COM2 at the same time, and we don't have a TEL either. And then as far as the listen switches go, you automatically listen to whatever you are transmitting on, but if you want to listen to a second radio while you're transmitting on the first, just select that radio, and now you're listening to that radio as well. And again, COM3 and TEL do not work. You can toggle the switches to go out on the PA or have the audio go out over the speaker, but that's really not going to do anything for you in Flight Simulator, but those switches work if you want to play with them. And then the marker mute button works a little differently. It is set to where you hear the markers automatically. And if you don't want to hear them, you select this key and that will turn the white arrow on. And the white arrow means that now that is muted. You will not hear markers if you start receiving a marker beacon. You can also select high sense, which turns the system to high sensitivity, which means you'll start to receive or hear the signals a little further away than you normally would. We also have keys down here to listen into our navigation radios. So if you want to listen into the ID for a DME or one of your nav radios or your ADF, you can do that, and the white arrow will tell you that you're doing that. The aux key does not work in Flight Sim. I believe that's for if you want to plug something into the system like an iPod or something like that. That's how you listen in on that, but that's not an option on Flight Sim. The squelch key does not work. This would normally break the squelch on the radio to where you hear everything, including the static. If you're getting a weak transmission, that's a good key to use to be able to hear that weak transmission a little bit better if it's not breaking the squelch, but that doesn't work in Flight Simulator. And then the play key does not work either. I think this is for like an ATC playback. I think some of these digital systems, they'll record the last 60 seconds of ATC and you can hit play to hear what they said, just as kind of a, if you, instead of asking the controller to say it again, you can hit the play key. I don't believe that functions, even though the light works up in Flight Simulator. These buttons are for your intercoms. If you want to just listen to the pilot, you click that one. If you want the pilot, co-pilot on the intercom, you hit that one. And then both, you can select both those keys, and then you control the volume for your passengers and let's see, I guess this is co-pilot and passengers, and then just the pilot. But those really don't do anything for you in Flight Simulator. The G1000 has a function where if one of the screens fails, it will automatically display all the essential data on the other screen. And I'll simulate a failure of the MFD screen here by turning off avionics bus number 1. And you notice what happens is when that screen turns off, I get all of the aircraft system data over here on the left. It consolidates the primary flight display over here, and it automatically pops up the map inset. So all of that information is now available on a single screen. That is supposed to happen automatically, but if for some reason it doesn't, if you have one screen go out and the other one doesn't display the backup data, that's what this display backup button here is for. You really should never have to use this in Flight Simulator. You really shouldn't have a screen fail. I don't know of any way to make one fail other than what I just did, and it did work with the automatic backup. But if you had one screen fail and the backup data didn't appear over here, you hit this display backup button, and that will automatically turn on all the redundant data on that single screen. To get it back to normal operations, just hit display backup again. Leaves your inset map in there, which you have to turn off, but otherwise everything goes back to normal. Again, the right display is set up as a multi-function display, which displays aircraft system information and big navigation display over here. The controls are again identical, and most of them function identically. So we have nav radio controls that work exactly the same as they did on the left side. We have autopilot controls, which are redundant and work as the same as they did on the PFD. We have comm radio controls, again redundant, and work the same as they do on the PFD. The baro set knob and the cursor control still work to control the altimeter setting and the CDI course on the left on the PFD over there. And then you have the GPS controls down here, which control do most of the functions for the GPS. Again, they're slightly different between the two, and we'll go into that into the on the GPS lesson. The range control is the only one that's significantly different, and it controls the range on the big moving map here. You can see the range display down at the bottom right-hand corner over here. It tells you the distance from your airplane to the edge of the screen. So currently it's 20 miles. If I rotate it left, it's going to zoom it in. If I rotate it to the right, it's going to zoom it out, and we can go up to 200 nautical miles on the range. Also, what is depicted on this map screen is dependent on your range as well. So as I zoom out, less things will be depicted. Right now I've got airports. If I zoom in, more airports will be depicted. Some of those disappear as I zoom out. VORs will be depicted as I zoom out, and then those go away when I get to the 200 mile scale. The display areas on the PFD, or excuse me, on the MFD are very similar. We have at least at the top, we have the nav radio display up here at the top. We have the comm radio display over here to the right. They're identical, duplicated from what's over on the PFD. We have some different GPS data fields up here. We have ground speed, desired track, and ETE. Again, we'll cover that more when we get into the GPS lesson. We also have a page display right here that tells us what page that we're on. It tells us both the page and the subpage, and we'll get into that here just a little bit as we show what we can select on the MFD for our page and our subpage. On the moving map, you have a wind indicator over here that gives you current direction and speed. So since the map's oriented north up, the wind's out of the south at 10 knots, and there's no way to configure this so it looks any different like we can on the PFD. It shows our current map orientation up here. We currently have it set up to be oriented north up, and there's a couple of different ways we can configure that, which we'll talk about here in a sec. And then again, it shows the range scale for the map down here on the bottom right-hand side of the map. And then we have soft key functions down at the bottom. Much simpler, not as many functions on the MFD, but we'll go over those here in just a second too. On the left side of the MFD, you have your aircraft systems displays, and these are going to be similar between different aircraft. You're always going to have engine power up here, typically fuel flow, and then engine temperatures and pressures down here. If you have a vacuum system, it'll be displayed. Fuel quantity is going to be on there somewhere, and then electrical systems information. For the 172 specifically, engine power is going to be the engine RPM. Then we'll have fuel flow in gallons per hour, and each of these tick marks is 2 gallons per hour. And then you have oil pressure, oil temperature, same as any other gauge you've seen on other airplanes. Red is bad, green is good, yellow is be careful, maybe do something about it. Then you have the exhaust gas temperature gauge, just like we had on the steam gauge 172. It will rise as you lean your mixture, but you really can't use it to set the mixture. We have the vacuum suction gauge that tells us the vacuum pressure for our standby attitude indicator gyro. Fuel quantity, a fairly precise indication of what our fuel quantity is. We have an engine hour meter, which functions similar to a Hobbs meter, just tells you how many total hours are on the engine. And then we have the electrical system status display, and it shows us the system status for the main battery, the main bus, and the emergency bus. This is basically the main battery. So it shows you voltage, amperage, and shows voltage for the system, and then amperage in or out for that battery. And then the emergency is going to be the emergency battery that's primarily there to keep the G1000 going if you lose your alternator. Shows voltage and amperage on that as well. The soft keys don't do a whole lot on the MFD. We have the map soft key, which if you hit the GPS, it has a toggle for turning topo on and off, but it doesn't do anything right now. You also have a tab for displaying weather data, and those can be selected independently of each other. I don't know if this will actually do anything if you have weather out there. I haven't really tried that out. Hit the back key to get back up to the next level menu. Then you have a declutter key, and basically this, when you hit it, will eliminate things on your map to make it less cluttered. The default flight simulator map is not the greatest map anyway, so I don't find a lot of function for this key. But if you feel like you have too much stuff on the map, you can use this declutter key to get rid of it. And that is all the soft keys on the MFD. There are a few different options available to us as how the map is oriented, or basically which way the map is turned. And our current orientation is always listed at the top right hand corner of the moving map. To change the orientation, we go into the menu key on our GPS controls, press menu once, and it will bring up the page options, and there's only one option available, that's map setup, so we hit enter. And then it brings up three options here. We want to make sure that the orientation field is highlighted here, and then hit enter to bring up the rest of the options. So our four options are north up, track up, direct track up, or desired track up, excuse me, and heading up. And north up is the default. That means that north will always be at the top of the screen regardless of the aircraft's heading, track, or course. And to change that, we go and use the big knob to scroll down. Track up is going to put our current aircraft's ground track up. I hit enter to select that. And so our current aircraft ground track is 159. So that means 159 is at the top of the screen, or basically south. 339 is at the bottom of the screen, or basically north is at the bottom of the screen now. This is your aircraft's track over the ground, and this does not account for wind. So this is not your heading. You'll notice the heading is pointed slightly off to the side here, and the aircraft's track is what's currently at the top. If I change this over to, let's see here. Always have to enter to get back into that field. If you change back into heading, you'll notice that it changes slightly here. Now the aircraft's nose is pointed up at the top versus when I was in the track up mode, it was slightly different. The aircraft's nose is canted because I have a crosswind off from the right. So that's the difference between the track and the heading mode. And another thing you'll notice about this mode is if I were to turn the aircraft, we'll take a little wider view here, you notice that the map is going to rotate as I turn, as I change either my heading or my ground track. So this is kind of a movable map if you have it in track up or heading up. The other option that we have is desired track up, and that will put your course line at the top of the map. And so currently our desired track to get to the next waypoint is 159. So 159 is going to be at the top of the map. And you'll notice even if I turn the aircraft, the map is not going to change its orientation right now because I'm not changing my desired track. Now, if I had a waypoint up here and I changed course at that waypoint, then yes, it would change as that course changes. But those are all of our different options for displaying orientation there. It's kind of a personal preference as to what you like. I like north track or track up. Excuse me, I like north up because that looks more like a standard map. But some folks do a little bit better if their desired track is up because it shows kind of where things are in relation to them as they fall on the map. The other option we have to display on the moving map is to display a fuel range ring, and it is underneath the orientation option. Just highlight the field underneath that says off, and then you can use a small knob to toggle it either on or off. When it's on, it will display a green and black dashed ring as to where you are going to run into your fuel reserve, which is what is calculated over here based on your current fuel quantity and your current fuel burn. And then it displays a solid green ring where you're actually going to hit the end of your fuel supply, where you're going to run out of fuel and your engine is going to quit. And this can be changed. You can toggle that on and off like we said here, and if you roll over here you can actually adjust what your reserve is. You'll notice I can adjust it down to say the VFR reserve of 30 minutes, and it tells me that in 31 minutes and at this distance at my current fuel burn and ground speed that I'm going to burn into that reserve. And then beyond that, it shows you where you're going to actually run out of fuel. And this is dynamic. You could actually set this all the way down to 0, and then the two rings are actually going to match up. But again, that is going to be the point at which you run out of gas, so you would not want to try to push that at all. It is also dynamic. So right now I'm doing 2450-ish on the RPMs. If I increase that and increase my fuel burn, that range ring gets a little smaller. And if I decrease that and decrease my fuel burn, then that range ring gets a little bit bigger. It's hard to see. As you can see, I've got it out on the 200 nautical mile scale right now, and I've intentionally put myself in a kind of a low fuel state to be able to see it. So most of the time on the 172, you're not going to be able to see that, but that is there. If you're curious how much gas you have left, or want to kind of have an idea of what kind of a buffer you have, if you can make that airport or not, then you can take a look at that, and that'll give you kind of a guesstimate. Again, it's dynamic. It's based on current ground speed, current fuel burn. So if any of that changes, this ring is going to change, but it will give you kind of a ballpark estimate of how far you can go before you're either pushing into your reserve or potentially running out of gas. And one more thing I'll mention is to get out of this view here, the easiest way is just to press menu twice. Although if you're in any menu, if you want to get out, just press this clear key and hold it for about 3 seconds, and that will take you from wherever you are, whatever setup you have in, back to your default moving map display. There are 4 different pages that we can display on our multifunction display, and we can control which page we select by using the big knob at the bottom right hand side of the display. Rotating through this will rotate you through the 4 different pages, and you get a little display down here. When you roll this knob, it displays that the current page that you have selected in blue, and then it displays the current subpage that you have selected in blue as well, and then the other pages that are available are displayed in gray. The 4 pages that you can select from are map, which is just basically your moving map. It only has one subpage, which is the navigation map. Then waypoint, which only has the airport information subpage. aux, which has only the system setup page. And then nearest. And nearest is a little bit different in that it has several subpages to choose from. And you can see again the page you selected is in blue, and the subpage you've selected is in blue, and you can use the small knob to rotate through the subpages, and then everything else that's available is displayed in gray. And the subpages that are available on nearest are the nearest airports, nearest VORs, nearest NDBs, and nearest intersections. So let's take a look at each of these pages and how we use them. The map page is pretty straightforward. It's just your moving map. We've talked about the options that are available there. The waypoint page has the airport information page that's available to you. What you can do is click the middle cursor knob here, and then you can use the cursor to enter an identifier for an airport, and it will give you information about that airport. It tells you it's a public use airport, tells you the name of the airport, what city it's located in, the elevation of the airport, the lat longs. It tells you the runways that are there, and you can actually scroll down with your cursor and take a look at the different runways that are available if you have more than one. GLH does not have more than one, but if there are more than one runways available, you can scroll through and get information. It gives you the distance on there, and then it also gives you the communications frequencies here. And when you scroll down with your big knob to highlight one of those frequencies, you can actually, if you press enter, it will enter that in your standby frequency. So if you don't want to look for it in a chart to go find the weather or tower over at Greenville, you can just select that, and it will enter in your comm radio standby frequency. You still have to swap it out, but it will do that for you. A little further down, it also has navigation frequencies. Again, if you highlight that to where it's flashing and press enter, it will put that up in your standby nav radio as well. The aux page only has one subpage again, and the only thing you can do here is change your COM frequency spacing. You can alternate between 1.833 kilohertz, which is what you use in Europe, and if you press the cursor here and then rotate the small knob, it'll rotate between your two options, the other one being 25 kilohertz, which is the standard in the United States. This is actually helpful to set up. If you hit enter, it will actually change it back again. So you need to hit the cursor to get back out of there. This is actually helpful if you are in the US, so you don't have to go through quite as many frequencies to get to the frequency you want. Unfortunately, there's not currently a way to save it in the stock G1000. You'll have to come in every flight and change it back if you like that frequency spacing. And again, the nearest page has 4 different subpages that we can look at. The first one is nearest airports, and this will give you a list of airports that are within 30 nautical miles or so from your aircraft. And then it gives you a bunch of information about that particular airport. So right now, KTVR is the closest airport to us, and it tells us that that's in Vicksburg. It gives us information on the runway and the runway length. Gives us the frequency information, and then gives us the approaches that are available at that airport. If I want to look at the different airports that are nearby, I just hit the cursor key and I can scroll between the different airports and get the information for that airport. There is no way to scroll down to these lower fields in this menu to like dial in frequencies or select approaches or things like that. But the one thing that you can do is when you have something selected, if you'd like to go there directly, you can just hit the direct key and it will populate that for you in your GPS, and then just hit enter when it highlights the activate field, and then that will take you directly to that airport from your present position. And the other subpages that are available in the nearest pages are the nearest VOR, nearest NDB, and nearest intersection. And again, just like the airport page, if you highlight or bring up the cursor and scroll down, it will give you the information on what kind of facility is. If it's an NDB or a VOR, it will give you the frequencies. And again, you can hit the direct key and that will take you directly. It will set you up to go directly to that particular waypoint, VOR, NDB, whatever, if you want to do that. One last thing I'll mention is that you have the ability to put a cursor on the map. You can do this on both the moving map and the small inset map on the PFD. To do this, you press the center of the range button. That brings a little arrow up, and that's your cursor. And then you can use the outside of the range knob to move that cursor around. About the only thing you really do with it, though, is push it to the edge of the screen and move the moving map if you want to look at something that's slightly off screen, but you can't put your cursor over like a VOR or a airport and select it and do anything with it. So I don't find it to be a particularly useful feature, but if you want to move your moving map around, that's how you do it. And then to get the cursor to go away and center it back up, just press the center of the range knob again. This concludes the first part of our tutorial on the Garmin G1000. Hopefully it's given you all the skills you need to make use of all the basic functions on this prolific piece of avionics technology. Be on the lookout for follow-up videos on using the autopilot and GPS on this panel in the not-too-distant future. As always, if you've enjoyed the video, please don't forget to like, subscribe, and ring the notification bell. Thanks for watching, and we'll see you next time.